talking about inelastic collisions. Your homework for tonight is just one problem. A 2,000 kilogram Jeep Cherokee traveling at 15 meters per second rear ends a 1,200 kilogram Honda Civic traveling at 7 meters per second. The bumpers of the two cars lock together. How fast are they traveling immediately after the collision? By the way, both of these velocities are positive, which means they're both traveling in the same direction. So we have talked a little bit about collisions, and you might remember there are two different types. They're called elastic and inelastic. In this lesson, we'll focus on inelastic collisions. An inelastic collision is where the total kinetic energy is not conserved. So that means the kinetic energy of the system, of all of the things in it, before the collision is not equal to the total kinetic energy of the system after the collision. We have lost some kinetic energy during the collision. So with inelastic collisions, some of the initial kinetic energy that we have is lost due to thermal energy from friction or potential energy, but it might also be gained if there is an explosion or something. So it might be that you have less kinetic energy after the collision than you did before, or you might have more. Either way, it is defined as an inelastic collision. And a completely or perfect inelastic collision is one where the objects stick together. And these are going to be the inelastic collisions that we will focus on. It's where you have two separate objects in the beginning, and in the end, they are one object with the combined mass of those two things. So in this example, we have a bullet, and it's being shot into a wooden block. Two separate objects. The bullet has a mass of little m, and the block has a mass of big M. When they hit, they become one single object, and the new mass of this object is the mass of the block and the mass of the bullet added together. Because they are now one object, that means there is only one final velocity. So in an inelastic collision, you have two initial velocities for two separate objects and one final velocity for the one combined object. So most collisions are inelastic. And the solution for them is pretty straightforward, but let me bring you through it. We know from the previous video that momentum is always conserved no matter what kind of collision it is. Momentum is always conserved. So momentum before has to be equal to momentum after the collision. So in a perfectly inelastic collision, we have two objects to begin with and one to end with. So we express the conservation equation as this. This equation is the same as the conservation of momentum equation in the previous video. This beginning part on the left is actually exactly the same. We have the momentum of object 1, which is mass times velocity, m1 v1, and then we have to add that to the momentum of object 2, mass times velocity, m2 v2. What's slightly different here, and that we have altered to explain inelastic collisions, is that now the final momentum of the system has one single velocity because there's one object, and the mass is now the mass of each of those objects added together. And just a little side note, if kinetic energy is lost, where does it go? Doesn't this violate a conservation law? So we have learned quite a few conservation laws in this class. We know the conservation of momentum. From chemistry, you learned conservation of mass. And we also recently learned the conservation of energy, which tells us that the amount of energy in a system always remains the same. The amount of energy you have before is equal to the amount of energy you have after. The thing that changes is the kind of energy. So, yes, kinetic energy is lost. We may have more or less of it after the collision than we did before. But all it did was change into a different kind of energy, like thermal energy or potential energy. We didn't actually lose any energy, it just changed from one form to another. So, go ahead and use this modified version of the conservation of momentum equation for inelastic collisions to try and solve the Jeep and Honda Civic problem up here. Make sure to write down all of the things you are given in this problem and what you need to know, and it may be helpful to draw a picture of before the collision and after the collision.